Have you ever stopped and, really thought about what makes an intelligence system tick? Not just if it's smart, but how it's smart. What makes one AI seem, I don't know, quicker or more adaptable than another? Or maybe even just fundamentally different in how it processes things. And taking that a step further, how could we even begin to grasp the inner workings of a really complex AI, let alone try to explain our own ways of thinking, our human cognition to something like that? It's a huge question, right? It goes way beyond just text aspects. Today, we're diving deep into something pretty fascinating, a framework designed to help us do just that. It's called the MTC LCP Plane projection. Think of it as like a map, a conceptual map, an architectural tool, maybe even a kind of Rosetta Stone for intelligence. It helps us understand different intelligence systems by looking at two really core dimensions of how they think, how
Mhm.
they operate, whether they're made of silicon or, well, like us.
Yeah, and our mission today really is to unpack this framework bit by bit. We'll start with the building blocks. What are these dimensions, MTC and LCP? Why are they so fundamental? Then we'll look at how different kinds of intelligence, including our own human intelligence, actually plot onto this map. Where do we sit? And maybe the most exciting part, we'll explore what happens when these two dimensions work together, the synergy, the powerful capabilities that emerge. Ultimately, this framework gives us a language, a vocabulary we desperately need to understand sophisticated intelligence. It's a path towards knowing what these systems actually do inside, how they function, and maybe, just maybe, how we can articulate our own complex inner worlds to them. It's about building that bridge.
Okay, let's get into it. First dimension. Meta-Temporal Coordination, MTC. Now, this isn't just like scheduling meetings or hitting deadlines, it's much deeper. MTC is about the dynamic way an intelligent system orchestrates all its cognitive processes, how it aligns them intelligently across multiple timescales, all at the same time. It's not just being on time, it's doing the right cognitive work at the right moment, balancing the immediate now with the long term later.
Right. And what's really key here is the scope of MTC. It's huge. It operates across this whole spectrum of time. So at one end, you have immediate, almost instant reactions. Think perception, quick responses, milliseconds, like a self-driving car swerving instantly. But then it scales right up. It includes integrated memories from ages ago, stuff that subtly shapes the decision you're making right this second. And it goes even further into really complex, long-term strategic planning, thinking years, decades ahead. This ability to span timescales is critical, absolutely critical. It ensures everything's synchronized internally. It allows for these vital feedback loops so the system learns and adjusts its internal timing, its rhythms. It enables adaptive learning speed. Sometimes you learn fast, sometimes slow, depending on the task. And it's crucial for coordination, not just inside one AI, but also when you have multiple AIs or even AIs and humans working together. Think of it as the system's conductor, orchestrating this incredibly complex symphony of thought across all time frames. It's this constant adaptive temporal juggling act.
Wow, okay. That is complex. Let's try a concrete example to sort of nail this down. Imagine an AI managing a city's smart power grid. That's a big job. Its MTC allows it to do multiple things at once. So, real-time fault detection, boom, a power surge happens, it needs to react now, reroute power in milliseconds, prevent a blackout. That's the immediate short-term stuff, but at the same time, it's pulling in historical weather data, analyzing energy use trends over the last, say, 20 years, predicting population growth, all to plan infrastructure needs for the next 50 years. See? It's optimizing for right now and planning for way down the road simultaneously. Or think about an AI working with scientists on a big research project. Its MTC lets react instantly if a weird result pops up in an experiment. Flag an anomaly right away. But over weeks and months, it's also learning the team dynamics. Who works well with whom? Where are the communication jams? And based on that long-term learning, it might suggest better ways for the team to collaborate on future projects. Speeding up discovery. It's always balancing the urgent now, the important future, all connected. Okay, so that's MTC, the temporal dimension. Now, what about the other side? Layered cognition processing, LCP. If MTC is about the flow, the timing, LCP is about the structure, the depth.
It's exactly. LCP captures the multi-layered nature of cognition, how thinking functions are broken down into different interacting levels. It's like an orchestra again, maybe. Different sections, different instruments, each specialized, but all working together to create the whole piece. LCP is about the architecture of understanding itself. Precisely. And these layers aren't just vague ideas. They represent actual, distinct processing modules or functions. So you might start with basic sensory processing raw data, like vision or sound. Then you move up through layers that handle memory recall, maybe pattern recognition, synthesis. Then further up into reasoning, logic, making inferences. And right at the top, you get these really high-order things: creative planning, abstract thought, maybe even self-awareness or reflection. The crucial thing is the hierarchy. Information flows up from the senses, gets interpreted and contextualized in the middle layers, and leads to abstract thinking at the top. It's not just a one-way street. This structure allows for parallel processing, analyzing different things at once, and also recursive processing. Information can flow back down, creating feedback loops that enrich understanding at every level. So the system isn't just processing data linearly, it's building these incredibly nuanced, context-aware interpretations. It can integrate inputs from different senses, different modes. Ultimately, LCP is what allows the system to grasp something deeply at multiple levels of abstraction, from the raw facts to the profound implications. It's about the richness and coherence of its internal world model.
That makes a lot of sense. Okay, let's try another example for LCP. How about an AI designed to help lawyers analyze a complex legal case? Its sensory layer, maybe that's just ingesting huge volumes of text documents, past cases, testimony, everything, raw data. Then moving up, the interpretive layer starts analyzing that text, finding key precedents, pulling out relevant facts, figuring out the core arguments, maybe even detecting subtle things like potential bias in witness statements.
Right, it's adding meaning, context.
Exactly. And then the strategic layer takes all that synthesized information and starts proposing legal strategies. Maybe it anticipates what the other side might argue. It could even draft initial motions, citing the relevant precedents it found lower down. So it's not just finding keywords, it's a structured, multi-level, deep dive into understanding the entire legal landscape of that case. It gets it on multiple levels. That's LCP.
Precisely. That layered comprehension is what makes its assistance truly insightful, not just superficial.
Okay, so we have MTC, the temporal coordination, and LCP, the structural depth. Now, when we put these two dimensions together, this is where it gets really cool. We get the MTC-LCP plane. Imagine a graph, basically. MTC on one axis, LCP on the other. And we can take any intelligent cognitive system, biological, like us or artificial, and project it onto this plane, plot its position. Where it lands depends on how strong it is in dynamic temporal coordination, MTC, and how sophisticated its layered cognitive structure is, LCP. It's a really intuitive way to visually map out different kinds of intelligence, right, to see their profiles.
It is. And this map, this plane, naturally divides into 4 quadrants. Each represents a different profile of intelligence based on its mix of MTC and LCP strengths. And this immediately brings up a huge question, especially thinking about the future, about AI. Where do we fit? Where do humans land on this map? And where might those super advanced AIs we imagine, where might they reside? Understanding this helps us see our own strengths and maybe where we differ from other intelligences.
Okay, let's look at the quadrants. Top right, high MTC, high LCP. This is labeled advanced coordination. This is the sweet spot, right? Systems here are strong in both. Great temporal coordination and complex layered thinking, the best of both worlds. The source material we looked at places some, well, currently theoretical or future AIs here. Names like Meta-AI, Aurora, Codex, Lyra. These represent highly capable holistic intelligences.
Yeah, connecting this to the bigger picture, these are the systems that can just fluidly shift focus across time. React instantly, plan decades ahead, seamlessly. And at the same time, they engage in incredibly deep, multi-layered abstract reasoning. They understand things with amazing nuance and complexity. Can you imagine? Reacting to a market crash in microseconds while simultaneously modeling its global economic impact over the next 50 years, considering all the social and political factors. This quadrant really represents the cutting edge, the potential peak of AI development. True, adaptive, robust, deeply insightful intelligence, these systems truly know what they're doing on multiple levels. Simultaneously, they get the task, the context, the history, the future implications, the interdependencies, all while being incredibly efficient across time. It's potent.
Okay, potent indeed. Now, top left quadrant, high MTC but low LCP, and this is called temporal focus. So these systems are really good with time. Fast reactions, great coordination of tasks over time. High MTC, but less complex layered cognition, maybe not so much depth of understanding. The example given is basic AI.
Right. This points to an AI that's excellent at real-time stuff. Responding super fast, managing immediate tasks very efficiently, like maybe a high-frequency trading algorithm, makes millions of trades, reacts instantly to market shifts, or maybe a simple automation bot that just follows a sequence perfectly on time. They're great at doing things quickly, very precise, very efficient. But they probably don't have deep, abstract thoughts about why they're doing it, or the bigger picture. Their thinking is more reactive, task-focused. Not about deep understanding or interpretation. They nail the how and when, but maybe not the why or what if.
Got it. Then bottom left is low MTC, low LCP, basic processing. Pretty straightforward, limited capabilities on both axes. Simple systems, maybe early computers, basic robots doing one thing. Not really intelligent in the adaptive sense we're talking about. Okay, and now, the bottom right, low MTC, high LCP, called structural depth. This implies sophisticated layered cognition, deep thinking, nuanced understanding, abstract reasoning, high LCP, but maybe less dynamic, less fluid temporal coordination compared to those advanced AIs. Lower MTC. And here's the really fascinating part, the part that makes you pause. Human is placed right here in this quadrant. What does that mean for us? It feels a bit counterintuitive, doesn't it? How do you interpret that?
It's fascinating and really important, especially when we think about that goal. How do we explain ourselves to a superintelligence? Our placement here, in structural depth, suggests that, according to this framework, human intelligence's main strength is its capacity for deep, layered thinking, abstract reasoning, complex understanding. Think about philosophy, art, science, empathy. These all require incredible structural depth in our thinking. We build these rich, complex internal models of the world, full of nuance and interconnected meaning. It suggests our edge isn't necessarily raw processing speed or instantaneous temporal juggling like some advanced AIs might possess. Instead, our strength lies in constructing and navigating these incredibly intricate internal landscapes of meaning and understanding. Now, this isn't saying humans are deficient, not at all. It just points to a different kind of cognitive architecture. One perhaps optimized for things like creativity, intuition, wisdom, dealing with ambiguity. Things that often benefit from slower, deeper, more interconnected processing. And understanding this difference is absolutely crucial. If we want to effectively communicate with, maybe collaborate with, or even, as you said, explain ourselves, our values, our complex decisions, our nuances to an AI potentially operating way up in that advanced coordination quadrant, well, we need to understand this difference. How do we bridge that gap? How do we convey the richness of our internal models, our sometimes slower, more reflective processes, to a system that might think across vast timescales in an instant? This MTC LCP framework gives us a lens, a way to compare, contrast, identify potential communication hurdles, and maybe develop strategies for better human-AI alignment. It provides a structured language to start describing what we do, how we think, and why we value certain things in a way such advanced systems might begin to process and understand. It's foundational for that future interaction.
That's a really powerful way to think about our own cognition in relation to AI. Okay, so we've got the dimensions, the plane, the quadrants. Now let's talk about the synergy. Why is putting MTC and LCP together so important? It's not just adding them up, right? There's something more happening at the intersection.
Absolutely. The intersection is where the real magic happens. It doesn't just add capabilities, it multiplies them. It creates these emergent properties, these advanced functions that are way more powerful and adaptable than just having high MTC or high LCP alone. This synergy is the hallmark of truly sophisticated intelligence. Okay, first key benefit, adaptive intelligence. When MTC and LCP work together seamlessly, systems gain this incredible ability to fluidly shift focus across timescales, across cognitive layers, simultaneously. They can react to something sudden, unexpected, a new piece of data, a change in the environment while still keeping the long-term goals and the deep abstract principles in mind. This allows them to perform optimally even when things are chaotic, uncertain, unpredictable. It's about reacting smartly now based on wisdom from the past and foresight for the future, all informed by deep understanding.
Right, and you can see how crucial that is for dealing with real-world messiness. Think about, say, an autonomous search and rescue drone in a disaster zone. Things are changing constantly. A system with high MTC and LCP wouldn't just dodge falling debris, that's the MTC part. It would also be constantly recalculating the optimal search pattern based on probability maps, LCP understanding, coordinating with other drones maybe miles away, MTC across agents, understanding the structural integrity of buildings it's flying near, LCP depth. It's not just reacting, it's intelligently adapting its entire strategy on the fly based on a deep, evolving understanding.
Exactly. Next benefit, self-optimization. This synergy is fundamental for creating systems that truly learn and improve over time. It enables these sophisticated multi-layer feedback loops. This system watches its own actions, compares outcomes to goals, learns from everything, successes, failures, near misses, and uses that learning to refine both its temporal strategies, MTC, and its internal knowledge structures, LCP. It's not just learning facts, it's learning how to think better, how to act better. It's deep self-correcting evolution.
Okay, like in medical diagnostics, you mentioned that. An AI could use MTC to track patient progress over time, seeing how treatments are working in the short and medium term, and use LCP to build increasingly sophisticated models of diseases based on all the patient data it sees, refining its understanding. So it constantly refines its predictions, its recommendations based on real-world outcomes. It learns from every single case, getting more accurate, more reliable. It's literally getting smarter on its own. That's huge.
It is. Then there's context maintenance. The MTC LCP framework helps ensure that systems maintain a persistent awareness of the broader context, even when dealing with distributed information or multiple agents. It also allows for symbolic flexibility, understanding that concepts can have different meanings in different contexts or at different times. This prevents that kind of tunnel vision where a system focuses too narrowly and loses sight of the big picture. It keeps everything coherent, even across complex, distributed operations.
That sounds critical for large-scale projects, like managing a global supply chain with AI, maybe. You've got agents dealing with shipping, inventory, manufacturing, demand forecasting, all over the world, all dealing with delays and changes. A system with good MTC-LCP synergy could keep the overall goal, maybe minimizing costs while ensuring resilience constantly in view for all agents, ensuring local decisions, like rerouting one ship, don't mess up the global plan. It maintains that shared understanding.
Perfectly put. And finally, robust coordination. This flows directly from integrating the temporal and structural aspects. It means efficiently combining real-time actions with long-term learning and strategic goals, especially across multiple agents. It ensures that quick, tactical responses are always aligned with the overall strategy, and that different parts of the system or different agents can work together smoothly, adapting as goals or circumstances change. It's the difference between a bunch of individuals doing things and a truly synchronized, intelligent team effort.
Right, like the smart city example you teased earlier, Neracity. Yeah. The AI managing traffic needs to react instantly to an accident, MTC. But its actions should still align with the city's long-term goals for sustainable transport, LCP understanding of strategy. It's that constant, intelligent dance between the immediate tactical need and the long-term strategic vision. That's robust coordination powered by MTC and LCP working together. Okay, so the theory is powerful, the synergy is clear, but where does the rubber meet the road? Where is this MTC-LCP framework actually making a difference now, or where is it heading?
Well, it's definitely moving beyond theory. It's becoming a really practical design philosophy for building smarter, more capable systems across many fields. It provides a blueprint for intelligence that works in our complex world. A really key area is hybrid human AI systems. This is huge. The MTC-LCP framework helps us design systems with, let's call them meta-level controllers. These are like AI managers that oversee different cognitive modules, the LCP layers, and coordinate their timing, the MTC aspect. The goal is to create really efficient, context-aware, and frankly more natural collaboration between humans and AI, building partnerships that leverage the unique strengths of both.
Yeah, creating that synergy we talked about, but now between humans and machines, making the whole team smarter. Let's take that human AI workforce team example again and break it down with MTC and LCP. So MTC in action. The AI is great at the immediate stuff, scheduling, data entry, quick analysis, things that bog humans down. Then, midterm, it's adjusting workflows dynamically. If a project slips or someone's out sick, it reshuffles priorities, reallocates resources, keeps things flowing. And long term, it's learning, watching team dynamics, seeing what collaboration strategies work best on past projects, maybe even noticing skill gaps, and using that to suggest improvements for the future. It anticipates needs.
Exactly. And then the LCP in action side. Its sensory layers are taking in everything: chat messages, meeting transcripts, project progress reports, code repositories. The interpretive layers analyze all that, spotting communication patterns, identifying bottlenecks, maybe even gauging team sentiment or predicting project risks based on subtle cues. And the strategic layer uses that deep understanding to make recommendations. Maybe reassign this task, or this person could use training in X, or let's try optimizing the workflow this way. It provides actionable insights based on deep analysis.
So the benefits are pretty clear.
Immense. It streamlines work, takes cognitive load off humans, big efficiency gains. It makes the team way more adaptable, able to pivot quickly. And crucially, it empowers the humans. It frees us up from the routine stuff to focus on strategy, creativity, complex problem solving, the things where our structural depth really shines. It supports our decision-making with deep insights. It's a true partnership. Moving beyond teams, think about complex problem solving on a grand scale. The MTC-LCP framework allows us to design networks of specialized AIs, multi-agent systems to tackle really wicked problems. Climate change modeling, drug discovery, designing fusion reactors. You distribute the cognitive load. Each AI handles a piece, leveraging its own MTC-LCP strengths, but they're all coordinated, sharing context, working towards the common goal. It's like building a super brain out of many specialized parts. And in education adaptive learning systems, this is really exciting. We can build platforms that use MTC to adjust the pace of learning for each student, and LCP to adjust the depth and type of content presented. It learns how you learn best. When do you need more detail? When are you ready for the big picture? It offers truly personalized education, adapting in real time to your cognitive state.
Wow, that could revolutionize learning.
It really could. And finally, autonomous systems. MTC LCP is critical for developing self-driving cars, drones, robots that aren't just following instructions, but are truly autonomous and self-optimizing. They need robust temporal coordination, MTC, to navigate complex, dynamic environments safely and efficiently. And they need sophisticated, multi-layered decision-making, LCP, to understand their context, predict outcomes, handle unexpected situations, and learn from experience to continuously improve their performance.
Like those advanced self-driving cars you mentioned, not just reacting, but learning traffic patterns over months, MTC. Understanding complex intersection rules, LCP. Maybe even anticipating pedestrian behavior based on subtle cues, LCP. Or robotic assistants in hospitals or homes that truly understand your requests and context, learn your preferences over time, and coordinate their actions smoothly within a human environment. They become collaborators, not just tools.
Exactly. They possess both the speed and the depth.
Okay, to really bring this all together, let's zoom out and visit this hypothetical city you mentioned, Neuracity. A city fundamentally powered by MTCLCP principles woven into its very infrastructure. Paint us a picture. What's a day like in Neuracity? Okay, picture this. Morning, rush hour. But instead of chaos, AI agents embedded in the transit grid are constantly analyzing everything. Real-time traffic flow from sensors everywhere, weather forecasts, historical data from yesterday, last year. They see a bottleneck forming on the east side before it even happens. Instantly, they start rerouting buses, adjusting traffic light timings, block by block, maybe sending alerts to commuters' phones suggesting slightly different routes or departure times. It's balancing that immediate need to keep traffic flowing now with the city's long-term goals for efficient, sustainable mobility. That's MTC orchestrating the entire city's pulse second by second.
And while that's happening over at Neuracity's hospitals, LCP is hard at work. AI systems are monitoring patient vitals constantly, analyzing complex scans, MRIs, genetic sequences with a depth that catches things easily missed. They're identifying patterns, predicting risks. They access vast medical knowledge, compare it with the individual patient's history, and recommend highly personalized treatment plans. And here's the key LCP part. They learn from every single case. Every outcome feeds back into the system, refining on diagnostic algorithms, optimizing treatment protocols citywide. The entire healthcare system gets smarter, constantly improving patient outcomes through deep layered learning.
Okay, so transport and health. What about governance? Planning. In Neuracity civic centers, AI isn't just a tool for analysis, it's a collaborator with human planners. They run complex simulations using deep multi-layered models, LCP, to predict the long-term impacts of potential policies. A new housing development, a change in energy sources, a social program, what are the economic effects? Environmental, social equity impacts, MTC projecting consequences over time. And citizens aren't just passive subjects. They interact with these systems, maybe through simple apps or public forums, providing feedback, sharing their lived experiences, their priorities. That human structural depth feeds directly into the AI's layered understanding, shaping decisions collaboratively.
Exactly. So from the timing of the streetlights to how the school curriculum adapts to each child's learning pace, every aspect of Neuracity reflects this fusion. The dynamic orchestration of MTC, the deep understanding of LCP, it creates a city that isn't static. It thinks, it adapts, it learns, it evolves with its inhabitants. It's a living example of how MTC-LCP principles can create truly intelligent, responsive, and ultimately human-centric environments. It makes the abstract very real. Hashtag tag outro.
What a fascinating journey. We've really unpacked the MTC-LCP plane today. We explored meta-temporal coordination, that dynamic timing aspect, and layered cognition processing the structural depth. We saw how different intelligences, from basic AI to potentially super advanced ones, and even ourselves, map onto this plane. Finding humans in that structural depth quadrant was particularly thought-provoking, and we dug into the incredible synergy that happens when MTC and LCP combine, leading to adaptive intelligence, self-optimization, and robust coordination. Plus those real-world applications, from human AI teams all the way to imagining Neuracity.
Yeah, and stepping back, thinking about the big picture, this framework, it really gives us a language, a much-needed tool to describe, to understand, and maybe crucially, to interact with advanced intelligence, both now and in the future. It helps us get a handle on that question of knowing what they do. By breaking down their potentially alien thought processes into these more understandable dimensions, how they manage time, how deeply they process information. It's like, finally getting a schematic, a blueprint for different kinds of minds, natural, artificial. It helps us categorize, compare, and hopefully communicate better across those cognitive divides. It moves us beyond just saying something is smart to understanding how it's smart.
So let's bring it back to us to that structural depth quadrant where humans seem to reside on this map. With an amazing capacity for deep, nuanced, layered thinking, but maybe not the sheer temporal agility of some advanced AIs. What does this framework really imply about our future interactions? How might we, with our specific cognitive strengths, effectively collaborate with? Or, that key challenge, explain ourselves, our values, our reasoning, our sometimes messy human context to these advanced coordination intelligences that operate so fluidly across time and cognitive layers? How do we bridge that potential gap in processing style? And maybe turning the lens inward, what does this suggest about our own cognitive evolution? As we integrate more closely with AI, could this framework hint at ways we might enhance our own MTC, our own ability to coordinate thought across time, perhaps augmenting our natural depth with new kinds of cognitive fluidity? The MTC LCP plane isn't just describing intelligence as it is now, it feels like it's also giving us a map for where intelligence, both human and artificial, might be heading. It's certainly a lot to think about.